As we're looking at Claire, we can't think back to that warm-up, that strategy for doing some mental math. Claire is making this statement. Claire is saying this equals this. All I want you to worry about right now is proving whether Claire is right or wrong for the 10 plus 3, 10 minus 3, being the same thing as 10 squared minus 3 squared, okay? Prove her right or prove her wrong. That's what you're doing right now. So we're going to check out these 10s. So we're going to prove whether they're the same or not just by doing the order of operations. So 10 plus 3 is 13. 10 minus 3 is 7. 7 times 13 is 91. Everybody good with what I just did right here? Okay. Then Claire's making the statement, it's the same as 10 squared minus 3 squared, which is 100 minus 9, which is 91. So it looks like Claire's strategy currently checks out. Everybody seeing why?
Well, we'll see about how long that lasts.
Let's see how long that lasts. So you're going to try to see if Claire also made the same similar statement for 20 plus 1 times 20 minus 1 and 20 squared minus 1 squared. I want you to test it out. Is she right or is she wrong? All right, so let's run through what this is. I got a 21 minus, times 19. What's 21 times 19? 399. It was in our warm-up even. Okay. So let's do this. 400 minus 1. Claire's right again.
You will.
21 times 19. So, all we've done so far, Dave, is we've proved Claire's little strategy is correct. Because either way I did it, we got the same answer. I want you to try her strategy to rewrite this. Let me get some different highlighters to get organized. Rewrite. Oh yeah, that's a good color. Rewrite this like these. Okay? Try that out. Rewrite that like those. This is what I heard. At least 3 different places. I keep trying to write with that highlighter. 100 squared minus 25 squared. If what Claire says is true, this should work. So we're going to test it out. Well, we're going to test it out. We're going to do 105 times 95. And that is 9,975. Hey, we'll hang tight. And if I do 100 squared minus 25 squared. No, that's not 25 squared. I messed that up. That should be 5 squared. We were getting ahead of ourselves. If I do 100 squared minus 5 squared, I also get 9,975. I got ahead of myself with that 25. 5 squared is 25. So it did work. Yeah. Looking at number 3, we're about to look at it together. We're going to prove why it works. Are you guys noticing that we had a plus 1 minus 1, plus 3 minus 3, plus 5 minus 5? There's always a plus minus of the same thing happening, right? So check this one out. Plus 4 minus 4. So we could assume that this would also work with an x. X is just a number we don't know. So if it worked with 10, 20, 100, we could also assume it works with x. This table, shout out James, my man James in 5th hour loves these tables. Okay? X times x.
That's my dog.
X times x. X squared. 4 times x. Negative 4 times x. 4 times negative 4.
Negative 16.
Which is 4 squared, right? Negative. Okay. Look what happens with these two. What's happening with those?
Oh my
They
God.
cancel. For the same reason that the b term yesterday, right? How did we get the b term when we had ax squared plus bx plus c?
Cancel.
How did we get b every time? What operation? Add. What happens when we add these? No, what happens when we add 4 negative 4? 0. Guess what 0 times x is? The b term is gone. Okay? So, x squared minus 16 is standard form for x plus 4 times x minus 4. The reason the b term isn't there is right here. Negative 4x and 4x cancel each other. Negative 4x and 4x cancel each other. When I add them together, that is b. b is 0. That's not a new big idea from yesterday. Add to get B, multiply to get C. Well, when we add something in its opposite, it is 0. So, let's see. Does that translate to x plus 4 squared, do you think? 30 seconds. Turn and tell your partner, and then we're going to talk about it. We're going to focus on the big idea that we get the B term by adding. If I add, what would my B term be? 8x.
I don't know.
Is there anything to cancel out the B term if it's plus 4 plus 4? No. So this does not work unless I have one of each. Ooh, that made a cool smiley face.
Cute.
Right there, look at it.
Yeah.
Nice. I want to fill in the fours. Yeah. Kind of looks like this. I don't know. So, let's practice this.
South Park.
ax squared plus bx plus c. We're going to add to get b, multiply to get c. So if I add, what's my b term? 0. Negative 10 and 10 is 0. Remember we talked about that canceling thing? When I multiply, my c term is 100. I need you to do that for the next two, and then stop. As we're going factor to standard, it's helping us see how it's working, and it'll be easier to go than from standard to factor. So 2x times 2x gives me the 4x squared. And then because that plus 1 minus 1, what's happening to my b term? It's canceling, and I'm left with a negative 1. Negative 1 times 1, negative 1. Okay, the next one, 4 times 4 is 16. What's happening to my b term, my 4x minus 4x? Gone. I'm left with minus x squared. You could write it, some people prefer to write it as negative x squared plus 16. It's the same thing. Okay? What is that? Yes, so is the 16. But right here is a 4x, and right here would be negative 4x. The negative 1 times 4. Are you seeing the positive negative cancel there? Okay, good. Thanks for bringing that up. So this next one, here's what I know. I know I need an x times x. I know to make a negative c term, I need a positive and negative, right? And I need it to cancel. So to get 81, but get the b terms to cancel, what two numbers do I need? I need a 9 and a negative 9. I'm just going to point this out to the side because it's going to help us in a minute. The square root of 81 helped us do that. Okay. 9 times 9. So I'm going to let you do the next one yourself. I'm going to jump down to the 9z squared. How do I get 9z squared, do you think? What times what? Nico? Yeah, how am I getting that 9z squared? Well, I'm going to go 3z times 3z to start. That's how I get 9z squared, right? So also, just notice square root of 9 is 3. And then, Nico, you said it. How'd you get that other number? Square root of 16, right? 4. No, this one we're doing together. So there's that plus 4 minus 4. And the reason that's working is there's a 12z and a negative 12z that cancel each other. There's no b term, right? Okay. I want you guys to then try these two on your own. They're similar to the ones we just did together. So, how am I getting that 49, y'all? 7 times 7. Okay? How am I getting that negative y squared? Minus y plus y. This 7y and this negative 7y are canceling. That's why there's no b term. So we're looking for something to cancel. No b term. We jump down to this 25t squared. I got 5t times 5t to make that happen. And I need something to cancel. 9 and negative 9. Because the square root of 81 is 9. That's y. Okay. We're going to do this next one with that square root stuff we've been talking about. This one looks kind of like funky, but it's not. So right here, I got c squared. I can add my other things. When I add my 2/5 and my negative 2/5, what happens? Cancels. So then I multiply them and I get negative 4/25. I'm just going to point out the square root of 4/25 is 2/5. 2/5. Okay? The square root of 4/25 is 2/5. I want you to try this one with the star next to it, right here. I'll put 2 stars next to it so it stands out. So I get 49/16 by doing what times what? 7/4 times 7/4. And then I get that plus D minus D. All right. So that's going to make, because the plus minus, my B term's canceling. 7/4 times 7/4 is 49/16, so that proves that that's good. And then D times negative D is negative D squared. So it's all there. Now this next one. Most common wrong answer. You ready for it? Most common wrong answer.
Oh, darn.
Well, for the B term, is there anything to cancel?
No.
No, the B term happens from adding. So if I add 10x, there's nothing to cancel the B term here. This is what we were doing like yesterday. It's in there so you can see the difference. You can't just keep doing that same thing. It's really important we have a positive and a negative that cancel. And then these next two we're going to roll through together too. We kept taking the square root of these numbers, right? And Brielle asked a good question. She said, there isn't a square root of 6, or there's not a nice square root of 6. And I'm going to agree. Check this out. The square root of 6 is the square root of 6. I know these are going to cancel because square root of 6x and negative square root of 6x cancel each other regardless of what the square root of 6 is. Right? You're not likely to get this on a test, but this is the same reasoning everything else has had. And then for this last one, to get rid of the B term, what have we always had in terms of signs, positives and negatives? To get rid of the B term, we've always had what? One positive, one negative.
One positive.
Once I have a positive and negative, how can I get a positive 100 for my C term?
Oh.
You can't. Because if one's positive, one's negative, guess what it would have to be for C?
Negative.
It'd have to be negative. So this one is no solution. No. Why? So Prince has a good idea here. He's saying let's try to solve it using the square root. Well, we would subtract 100 from both sides.
That would leave us with negative 100.
And guess what? You can't take the square root of negative. No answer. Something kind of important to point out.
That's a good question.
No answer does not mean the answer is 0. 0 is legit, straight up a number. 0 is an answer. No solution and 0 are two different things. No solution is no answer. 0 is an answer. So if we're considering... so, big point here is no answer would look something like this. An answer of 0 would look something like this. Right? 0 is an answer. It is a number.